Welcome one and all. Today we will see how to convert a non-exact differential equation into exact differential equation. In the previous sessions we have discussed some forms, some methods where we can convert a non-exact dA as exact in different methods. One is 1 by the integrating factor is of the form 1 by mx plus ny. This is the one form. Another form is 1 by mx minus ny we have discussed, and another one more is 1 by m into integral of dou n by dou x minus dou m by dou y. So if it is a function of y alone, then the integrating factor is e power integral of f of y dy. So these are the methods what we have discussed whenever the given differential equation is of the form some m dx plus n dy is equal to 0. So the differential equation is of the form m dx plus n dy is equal to 0, but it is not exact. And then so in the previous sessions we have discussed these forms. The integrating factor is of the form 1 by mx plus ny if the dE is a homogeneous dE, and if we have the product terms in the dE, then the integrating factor is 1 by mx minus ny. So if any dE's are not of these two cases, then 1 by m into something, if it is a function of y alone, then the integrating factor is of the form e power integral f of y dy. So similarly now today we will see one more method. So now first of all, as usually, whenever you identify any equation is of the form m dx plus n dy is equal to 0, and you just calculate dou m by dou y and dou n by dou x. If suppose both are not equal, then of course it is nothing but it is not exact. Then first of all, one by one we will check if it is homogeneous or not. If it is homogeneous, then we can take 1 by mx plus ny as the integrating factor. Otherwise, if we have product terms, after taking y as common in m and x as common in n, after that also if we have the product terms, then we can take the integrating factor as 1 by mx minus ny. If these two cases fails, then we will check for this 1 by m into something. Okay, if this one also fails, then we have to check this function 1 by n into dou m by dou y minus dou n by dou x. Just we have to check this one. So if it is a function of x alone, some g of x means a function of x alone. So if it is a function of x alone, then clearly the theory says that the integrating factor of the dE is of the form integral g of x dx. Then later on the procedure is same, just you multiply the given dE with this integrating factor, then automatically this given dE reduces as the exact differential equation, and for that we can find out the general solution as usually. So for whenever you will compare these two, so these two whenever you will compare, okay, so whenever we take 1 by m into something, then it must be a function of y alone. So if you take 1 by n into something, then this must be a function of x alone. So these are the only differences, just what we have to identify and observe. Now for this method 1 by n into something, whatever we will have, we will discuss with the help of one problem. So the problem is given like this. So 2xy into dy minus of x square plus y square plus 1 into dx is equal to 0. So we just take this as some equation 1. Okay, now as of all, first of all, it is in the form of m dx plus n dy is equal to 0. First of all, we will check whether it is exact or not. Okay, you write it. So clearly equation 1 is of the form m dx plus n dy is equal to 0, where where what is m here, sir? Here if you observe, this is dy and here it is dx we have. So means the coefficient of dx is nothing but m, means here m is nothing but minus of x square plus y square plus 1, in the sense minus x square minus y square minus 1, and n is equal to, n is given as here, n is equal to 2xy. So this is what n. Now as usually, first of all we will check whether it is exact or not. Okay, so you write this one. So to check the exactness of equation 1. Okay, so for that now we will calculate dou m by dou y, the partial derivative of m with respect to y. So dou m by dou y is equal to, so here x is a constant, means minus 0, derivative of y square is 2y, plus 1 is a constant, its derivative is also 0, means the partial derivative of m with respect to y is minus 2y. So similarly, now we will calculate the partial derivative of x, so partial derivative of n with respect to x, that is dou n by dou x. Dou n by dou x is equal to, here 2 and y both are constants, so 2 into y is a constant, so now the derivative of x is 1, so therefore the answer is 2y. Okay, now if we observe, here we got that, so dou m by dou y is not equal to dou n by dou x. So therefore we can conclude that equation 1 is not exact. You can write it. So therefore equation 1 is not exact, or is not an exact differential equation. Like that also we can write it. Okay, now we will check one by one. So equation 1 is not exact. So now what we have to check? So first case is whether it is homogeneous or not, we have to check it. So the given d is not homogeneous because here we have the term 1. So otherwise here it is a degree is 2, here also degree 2 and here also degree 2, but for this term 1 degree is not 2. So therefore here this one is not a homogeneous DE. So therefore 1 by mx plus ny is not an integrating factor. Similarly, next we have to check whether 1 by mx minus ny is an integrating factor or not. So but here we don't have the product terms. Suppose here if I take y as common, sorry, here in this x as common if I take, then no product terms. Here also if I take y as common, no product terms. So therefore 1 by mx minus ny is also not an integrating factor. Now the thing is, for the third and fourth cases, if you observe, so here dou m by dou y minus dou n by dou x, so here also we have the same, but only the negative sign is different. So 1 by m, if you take in the denominator, if you take x square plus y square plus 1, then it may not be simplified. So that's why better we will go with 1 by n into something and we will check it. Okay, so we will check that one now. Now we will consider Now we consider 1 by n into dou m by dou y minus dou n by dou x. Now we will calculate this one. So and we will check whether this is a function of x alone or not. So which is equal to, what is dou m by dou y? We have minus 2y, and dou n by dou x is also 2y. So divided by n. N means we have 2xy. So this is equal to minus 4y divided by 2xy. So here y cancels out and 2 cancels out twice. So the answer is minus 2 by x. Minus 2 by x means it is nothing but a function of x alone here. You can call it as some g of x. Okay, so here if you want you can write which is a function of x alone. Okay, so therefore we can say that the integrating factor of equation 1 is of the form if is equal to e power integral g of x dx, because here we got it as a function of x alone. So therefore by the theory we have that the integrating factor is of the form e power integral g of x dx. Now we will calculate that is equal to e power integral g of x, means here what we have, g of x is nothing but minus 2 by x we have. So g minus 2 by x, here you substitute, so which is equal to e power of minus, so integral of 1 by x, integral of 1 by x means log x. Okay, so which is equal to e power log of, by applying the basic logarithmic formula we can write it as log of x power minus 2 means 1 by x square. So e power log of 1 by x square means, so which is nothing but 1 by x square. So therefore the integrating factor of the dE is nothing but 1 by x square. Now we just multiply the dE with this integrating factor and we will observe what will happen. Now therefore by multiplying equation 1 with 1 by x square, because this is the integrating factor on both sides, then we get, so 2xy by x square into dy. Next we have 1 by x square into x square plus y square plus 1, this is the given dE, into dx is equal to 0. Now you just simplify this, so this one we will get 2y by x into dy minus of, so x square by x square means 1 plus y square by x square plus 1 by x square into dx is equal to 0. So this equation 2, let you call it as equation 2, this equation 2 must be exact, because here we got it as a function of x alone. So therefore here undoubtedly 1 by x square is an integrating factor. So therefore if you multiply the dE with this integrating factor, then the dE will transforms as an exact differential equation. So therefore we can directly find the general solution. So clearly equation 2 is exact. So therefore now we will find its general solution. Okay. Therefore the general solution of equation 2 is something like this. As you know that integral over treating y as a constant, we have to write some m1 dx plus integral of the terms in n1 which are free from x into dy is equal to c. Okay, so here m1 and n1 if you observe, so this is equation 2, so this is all nothing but m1 here, some m1 dx, and this 2y by x is nothing but n1. So because now this is of the form sum m1 dx plus n1 dy, so m1 is this one and n1 is this one. Now we substitute. So now what is m1 we have? Minus of 1 plus, so that implies by just we will substitute all the values here by treating y as a constant, minus of 1 plus y square by x square plus 1 by x square whole into dx, plus in n1 we have to take the terms which are free from x. Just here if you observe, here we have the term n1 is nothing but 2y by x, means there we don't have a term which is free from x, therefore we can write it as 0. So 0 dy is equal to c. Of course, where c is an arbitrary constant. So now this implies, so here integral of 1 means x. Next here y square is a constant, and integral of 1 by x square we have to calculate. 1 by x square means x power minus 2. So means integration is x power minus 2 plus 1 by minus 2 plus 1. So in the sense minus 1 by x we can write it. So means we can write it as minus 1 by x, and similarly for integral of 1 by x square is again minus 1 by x, okay, is equal to c. Okay, now you just simplify this, then otherwise by multiplying with this negative sign on both sides. Otherwise if you want you can take this x also as LCM. So if you take x as LCM, then we can write minus of x square minus y square minus x is equal to cx. We can write by taking x as LCM, we can write like that. So if you want you can multiply with this negative sign also, then we can write it as y square minus x square so y square minus x square plus x is equal to cx. So which is the finally the general solution for given differential equation. Otherwise here also we can write it. So which is the general solution of the given differential equation 1. So this is how we can solve, or we can convert a non-exact differential equation as a exact differential equation with the method 1 by n into something. So 1 by n into dou m by dou y minus dou n by dou x. If it is a function of x alone, then the integrating factor we can calculate it as e power integral g of x dx, and then by multiplying the given dE with the integrating factor we can convert that one into into exact, and later on, so by using the exact differential equation solution procedure we can find out the general solution of the given differential equation. Thank you.